and say no. And he's like, all right, here we go. We're going to start with some vocab. The first vocab word is point estimator. And this is extremely important if you think about a point estimating. Yeah. Okay. A point estimator is a statistic that provides an estimate of a population parameter. Okay. I'm assuming that you have forgotten everything over the last 2 weeks. And so, just to remind you, the parameter is the whole population and the statistic is from the sample. Okay, so let me say that again. It's really important. The parameter is from the whole population. The statistic is the sample. The P's go together and the S's go together. Okay, we're going to work with two of them in chapter 8. Do you guys remember the two that we worked with in chapter 7? Sampling distributions of two different things. Think about your yellow sheet. There's two different ones. Means and no. Population proportion. Yeah. Okay. So those are the two we're going to work with in chapter 8. The first one is going to be P. Which will be estimated by P hat. So this is the true population proportion, which we will never know usually. Why would we do statistics if we knew it? Which we're going to estimate using the sample proportion, which is P hat. Okay, the other one is the population mean. Estimated by the sample mean X bar. So this is the true, this is the sample, this is the true, this is the sample. Okay, if you can just try to focus yourself down to that being those two things, it's really going to help you. Okay, confidence interval. This is what we're working on in chapter 8, and I think chapter 10 also. Plausible. It's plausible. Okay, after you write this down, I'm going to pause and show you the joke because the joke is actually a teaching joke today. It's funny though. I mean, I think it's funny still. Okay. So let's pretend that you guys are interested in the average height of all of my squishmallows. No. Let's not discuss how many squishmallows I have. That would be embarrassing. But okay, let's just pretend you guys are just dying to know the true average height. It wouldn't be that hard for me to go home and measure them all, right? I mean, it wouldn't be terrible. Okay, but what we might do is we might take a sample. It'd have to be weirdly random, like you'd have to close your eyes and stick your hand out and grab a squishmallow, a random sample and measure those. Do you think that your sample average height would be the same as the population? exactly the same. So if I have, I don't even really want to estimate it, because, okay, let's just say I have 1,000, I don't. I'm just picking this number because it's crazy. If I had 1,000 Squishmallows, I don't really have 1,000 Squishmallows. I wanted to pick something just ridiculous, because I don't want you guys to sit there and guess how many Squishmallows I have. So let's pretend I have 1,000. Okay, if I take a random sample of 30 Squishmallows and measure those, do you think that's gonna be the exact same as all 1,000?
No.
No, and if I take a different 30, and then a different 30, and a different 30, are those all gonna be the same as each other?
No.
No. You guys know what that's called? Yeah, sampling variability, yeah. Okay. Sampling variability. Okay, anyway. So do you think that it might be useful to say, okay, our best guess is this, but we're probably off a little bit. Okay, and this is like a motion I want you to see that I'm doing over here annoyingly. Okay, so this is our best guess from my sample, but we're probably off a little bit in either direction. We're not really sure. It's probably somewhere in between here. That's what a confidence interval is. It's giving you like a range of what it could be based off of a sample. Okay, there's two parts to a confidence interval. First, I want to show you the joke because it's, like I said, it's a teaching joke today. And I'll probably refer to it a lot. It has to do with Garfield. Okay, so it says, taking a look at tomorrow's weather, the high temperature will be between 40 below zero and 200 above. And Garfield says this guy's never wrong. Okay. This range is really, so how confident is the weatherman?
Very confident.
Very confident because he chose a really, really huge range of values. Okay, so we could say that we're 100% confident that it's going to be somewhere between 40 below and 200 above, somewhere. Okay, so that's an example of a confidence interval. If you pick a giant range, you can be really confident about it. If you narrow down your range, you're not as confident. Does that make sense? Okay, I'm gonna come back to this. He's so cute. I really like Odie though. Do you guys know who Odie is? He's so cute. Okay. So confidence intervals have two pieces. The first is the point estimate. And that will be the center of our interval. Okay, and then the other piece of the confidence interval is called the margin of error. Have you heard these words before in a different class? You should have heard it in like Gov or Econ. A lot of polls, when they talk about like a survey, they'll say like 7% margin of error. No, never heard of it before? What?
I did not learn day trading from that.
You have? Okay. So we're going to draw a picture of a confidence interval. And in the middle is going to be a dot, and that's going to be your point estimate. And you're going to get that from a sample. I just wrote that wrong. I was gonna write form instead of from. And it has a symmetric margin of error on either side. So what you're saying is I get this from my sample, but I might be wrong all the way to here, and I might be wrong all the way to here. And the more confident you are, the wider this needs to become. Okay, what I want you to do right now is just pause for a second. And I want you to picture something that's living there that I haven't drawn. And you're not going to draw this. Just chill for a second. When I draw a confidence interval, I want to picture a normal curve or a histogram or something like that living above it. And so this is the middle of that distribution, and this is how far out the tails go. Do you see it? So this is a like one-dimensional version of a two-dimensional curve, histogram, something like that. Dot plot, anything. Okay, now for algebra's sake, because we're going to do math, we write a formula for this, which is point estimate plus or minus margin of error. Does this make sense? Like, makes sense to you? So point estimate being the middle, the minus is this part, and then the plus is this part. Do you see it? Are you exhausted? Okay, now you're going to be very upset when I move this paper because those two interpreting sentences are next. And so you can be very upset with me. I understand, but we have to get it over with. So if you could just make a very, very audibly angry noise in 3, 2, 1. Yeah, that's it. That's it. Does it feel better? Okay, this is the top one here. Is that sentence I was referring to that I highly suggest you read to yourself. You know, like Duolingo, you know, like like just break out the sentence every day and read it over. Yeah, exactly. Just set yourself an alarm, wake up, read my interpretation sentence for the day. Except for that it's the same one every day. Because there's only 2 of them, and the bottom one you don't need to memorize, I promise. Because you just will. You know what I mean? Like you're gonna use it in math problems, so
Put it above my-
yeah. That's what you need. You need to write it on Post-its, put it on your mirror. It's your senior quote.
Come on, Dad, we feel like an-
Like many random Owens. Okay, while you guys are writing, I'm gonna draw something back here, because I need to, I want to explain this sentence with a, I don't know, an example that I don't want you guys to have to worry about writing, but. Yeah. You guys all ready? Almost? Nope. And I've got a bunch of added. I got two of them. Rainbow Big Feet. Or Rainbow Big Feet, green Big Feet. Okay. All right, guys, so look back here. I want to explain this sentence, the interpreting confidence level sentence, because it's so wordy and meaty and weird. I want to explain it with a picture. Pictures are better.
Yeah.
Okay, let's pretend that this is the distribution of all of my Squishmallow height.
Yeah.
These are the really tall ones, the really big ones up here, the Costco size, right? And then these little guys down here are the little like clip ones that I have on my backpack. Don't look at my backpack. They're really on there. I also have these like little baby ones that I made into magnets. Anyway, let's just, okay, these are really tall ones. These are the really short ones. I just picked this number out of nowhere. I'm saying the mean is probably around, most of the Squishmallows are like 8 to 10 inches tall. Okay, can you guys, is this okay?
Yeah.
Do you picture how many, and it's probably not perfectly normally shaped, my distribution of Squishmallows, but pretend that I just drew a curve over it. Okay, got it?
Yeah.
Okay, now, say I go home, I put all my Squishmallows in a pile, I blindfold myself and I randomly choose 10, okay? And I measure all 10 and I get like a height of whatever this is, let's just say it's 5 inches, okay? And then I do some math that you guys don't know how to do yet, and I find my margin of error is here. Okay, what you're hoping is that the real number is somewhere in your confidence interval. So let me say that again. What you're hoping is your real number is somewhere within your confidence interval. Okay, and how often is it going to be in there is the percent confidence. So let's say I do a 95% confidence interval. Usually they're 90, 95, and 98 are the most three that we do in this class. 95, 90, and 98 are going to be kind of wide. This is too small for that, but we're just pretending. Okay, so this did not get 8.75 in it, so this would be a miss. Think of like Battleship. Do you see that this did not get quite to 8.75? Okay, but let's say I got a different sample and I got some bigger ones in that sample, this would be a hit. Yeah, I hit your ship. I hit the 8.75. The 8.75, the real number's in there somewhere in between. Okay, and then let's say I got, a sample that was pretty good. And then let's say that I got one that was a bunch of big ones, which is probably what's going to happen more often if you think about randomly selecting blindfolded Squishmallows, probably going to get too many big ones, just saying. But anyway, okay. I hit, in this case, 3 out of the 4 times. Do you see it? That I hit 3 out of the 4 times? Okay, if I kept doing this forever, or not really forever, 100 times, how many of them do you think would be hits? 95. Yeah. So if I repeated this math 100 times, 95 of the times should have the true value inside the interval somewhere. You don't know how to calculate any of this yet. We're just talking about the idea of it. So this is my miss because it didn't go up to the 8.75. So this is 3 out of 4 in this particular picture. Okay, but just imagine more going underneath. There would probably be 5 misses for every 95 hits. Okay, now, what it does not say. It does not say what the true value is. Unfortunately, we don't get to pick a range as big as Garfield's, right? We're never going to be 100% confident with our sample data. So we don't get to say, you don't get to take 10 of my Squishmallows and be like, the average is 8.75 because I got that from these 10. No, you don't know. You're not sure. You can do an estimate, but you're not sure. Okay, what else does it not say? Doesn't say anything about, well, Mrs. Talbot for sure has to have a 16-inch one because I got a sample that's around 10. So that means that she has to have a 16-inch one in there somewhere. No, you don't get to say that. You also don't get to say, the next time I do this, I'm gonna get a bigger one because she has more big ones in there. You don't know. You don't know. You don't get to say anything about the individual Squishmallows, and you don't get to say anything about what my future sampling might do, just because you took a sample and did an estimate. Okay, the last one is the hardest one to understand. This stuff, these two make sense to me. The last one's kind of hard. Okay, and this is something unfortunately that kids learn wrong, and I don't know how to prevent that. This picture does not say there's a 95% chance that 8.75 is in one of these. 8.75 either is in one of them or it's not. Yeah, it's 50-50.
What if you do?
It's saying if you repeat this over time, 95% of them will have it in there. But it's not saying there's a 95% chance it will be in there. I know that's kind of rough. Okay, anyway, make sure that you got this. We're not even going to go over that yet because we're going to use it so many times it's not even going to matter. Okay, now flip to the other side, and I believe you need to do arts and crafts next. Well, you don't like arts and crafts? You don't?
I do. I like arts and crafts.
Okay.
Well, I probably know what country that. Like, why are you looking nice for fall? I think I'll just. It's okay, I have A. I have A with, it doesn't have to be right. No, I think
By the way, just to let you know, I would have gotten this question wrong. I would have said hydrogen. It's nitrogen though. Did you guys know it's nitrogen? Yeah. You did? You didn't. You did? Again? I'm like, when did you learn that? I don't think. I know it's not oxygen, that's a trick question.
What do you say? What do you say when someone decides-
No,
What do we say when we want something?
it's really nitrogen.
To address the person.
I feel uneducated. But then again, I looked at the proportions and only 17 to 22% of people are getting it correct. So
Cameron, you doing that when you're the games right now?
we don't know why.
Yeah, I know, my dad. They do it for Then because W and done it, like, y'all know.
Nitrogen. It's really nitrogen? I feel like I should know that. Like, it's kind of important information to know, but I.
Preston did that. I'm not excited. Did they tell you the Lord? Did they tell you the Lord? They did. Preston was the one.
Did you write all of this stuff down, Francesca? Are you guys ready? See. Bilingual. All right, ready now?
Yeah.
Okay. A magazine recently asked a random sample of 1006, that's weird number, US adults, which gas makes up most of the Earth's atmosphere? A 95% confidence interval for the proportion who would correctly answer nitrogen is 17.5% to 22.5%, which makes me feel better about myself because only about 20% of people are getting this answer correct. Yeah. Anyway, okay. To do these problems, I find it best to draw a picture. So everybody draw the picture of a confidence interval. Just make sure that it's symmetric on both sides. I went out 3 boxes on both sides. Okay, and the low is 0.175 and the high is 0.225. Calculate the point estimate and the margin of error. This is the point estimate. And what we want to do is average them. Some advanced mathematics here. Okay. Does everyone understand how to find the point estimate? Okay, now the margin of error is the distance on either side. So I'm just going to take the high one minus the middle. There's a bunch of different ways to do this. Do you have any questions? Isn't this the best math ever? Okay, that was it for that. Okay, interpret the confidence level. This is one of the few times that we practice this horrible sentence. So we got to focus in the next couple minutes here. So flipping back to the notes, it says, it starts out with, if we select many, many random samples. Okay. If we select many, many random samples, nice, of size n equals 1006, comma, lots of different random samples of size 1006. We do some math, make confidence intervals for all of those. About 95%. Okay. And then what you want to do is you want to go to the problem and you want to find the word proportion or mean for the context. So here's the word proportion. Okay, I'm gonna say this a couple of times just because I love you. I know I'm gonna sound stupid, but whatever. If we select many, many random samples of size n and construct blank percent confidence intervals for each one, about blank percent of the intervals would capture the true parameter and context. Okay, I'm gonna say it again. If we select many, many random samples of size n and construct blank percent confidence intervals for each one, about blank percent of the intervals will capture the true parameter and context. Okay, now the next one, the other one, interpret the confidence interval. This is not the one I'm not worried about, but we haven't done it yet. So we are 95% confident. Low to high. Captures the true I know I've said it a bunch of times. We're not going to do the confidence level one very often. So you need to look at that one again a few times between now and the test. The confidence interval one, we're going to do a lot. That one will just become naturally memorized from how often we use it. Okay, but last thing before you can cut and paste while I'm talking. Do you understand the word captures in those? By looking at my picture, meaning the miss did not capture 8.75.
Yes.
But the hits did capture 8.75. Okay, so capturing meaning somewhere, it's located somewhere in the range. Yeah. Just check it.
On that.
Okay. My battleship thing helps, right? Does it help?
Yes.
Okay. All right, we're almost done, my dears. I know I can't sleep the night before we come back from break. I just can't do it. I slept totally fine the entire break. And then last night I woke up at 3:15 and stared at my alarm clock until 5:45. Thinking the whole time I have to teach all day. I need to sleep. This is crap. This is terrible. Why am I not falling asleep? And then I think of like the 1,000 things I needed to do today. And then anyway, I felt totally great over break today. Terrible. But tonight, there will be sleep. Tomorrow will be better. I don't understand. It's not like there's anything scary here. I've worked here for 20 years. Why am I like that? But I was like that when I was your age too. Like the first day of school, I'd always like have trouble sleeping the night before, which makes more sense. But this is like, I already know all you guys. Like, I don't know. I don't know what it is. I have no idea. Okay. If people guess 4 different answer choices at random, about 25% should get the answer correct. This is monkey guessing right here. Do you ever like watch a thing about monkeys like walking up, pressing a multiple choice? Like monkeys should be able to get 25% if there's 4 answer choices. Okay. Does the interval provide convincing evidence that less than 25% of adults would answer the question correctly? Okay, so take a look at your interval. Does this provide evidence that less than 25% of adults will answer correctly? Yes, why? Exactly. Yes. Okay, and what does that mean for the population of the US? That means that when answering this question, we're dumber than monkeys. For some reason, we learned this really, really wrong. I thought it was hydrogen. I don't know what my problem is. I know it's not oxygen. That's what they want you to believe. Or carbon dioxide. Those are my 4. No, I didn't even think of nitrogen, to be honest with you. I was gonna answer hydrogen, oxygen, or carbon dioxide. Nitrogen didn't even occur to me. Because I'm dumber than a monkey when it comes to answering this question. Please don't tell Mr. Sinatz any of that I just said, because I did take chemistry back in the day.